So I was saying, I am not an expert on passive house, although I'm a huge believer in this, and I'm also not an expert on mass timber, although I'm also a huge believer in mass timber. But where my expertise and what I would like to put forward the conversation today is around the topic of industrialized construction. So just a little bit about myself. I think it was mostly covered in the bio. I'm originally from California, but have spent the last 4 years here in Switzerland as an assistant professor. I also have 3 years of industry experience working for a general contractor and concrete contractors. So I would say that was probably the best experience I had in learning the challenges facing construction. And then I'll say a little bit at the end about what we've done to the Industrialized Construction Forum over the last 8 years, including our event next week. But let's kind of jump into this. Here's our research group where we focus on research and thinking about the future implications of industrialized construction. And in fact, I want to start with just the two main takeaways that I have for you today. If you take two things from my presentation, the first one is what I perceive to be industrialized construction as a holistic view that includes both a shift in technology and a shift in business models. And under business models, I would include things like supply chain, ecosystems and networks of suppliers. And then the second thing is that we have the opportunity for a whole new generation of both research and teaching in industrialized construction. And I think this is especially true for mass timber. I lost some of my lights, so I'm going to see if I can turn my lights back on. Good. Okay, so let's get into it. So part one, I want to just introduce industrialized construction as a shift in technology and in business models. And I've heard a lot of really great things so far about prefabrication, about mass customization. And I want to dive a little bit into that, a little bit more, maybe from an academic perspective that I bring. Let me start with this position. We're having a shift in technology, and BIM will never be the answer to all our problems. I think we actually had a really great example of the state of the art of BIM for mass timber. From the previous presentation. But I sincerely believe that BIM won't be an answer to our problems. And a main reason for that is because BIM is bringing digitalization. Digitalization is good, but digitalization is not the same thing as industrialization. We need to be very clear about the differences between the two. And before I get into that, I also think that digitalization struggles to solve one of the key problems we have in industrialization, which is an integration between design and fabrication. If you look at the traditional fragmentation in the built environment, where scholars position that we have actually 3 degrees of fragmentation. So we have a vertical fragmentation, and we're all familiar with this that work in the built environment. So you have design and construction operations, big gap between those two. And we saw good examples of how we need to bring those further together between design and construction if we want to achieve mass timber or passive house. We have horizontal degrees of fragmentation, which also exists between the trades, right? Structural, mechanical, electrical, plumbing. And then the thing that we don't often think about, which I'm going to challenge us today to think more about, is what we call longitudinal fragmentation, or the idea that we have fragmentation across projects. And this means that we exist in a project-based industry and our teams come together. We form a specific network of suppliers, an ecosystem for a single project. And we create a lot of really good digital processes, usually in the confines of that project. And the team is probably just getting up to speed right when it's time for the project to end. And now the team disbands and you put together a new project team. And maybe you have a few people that work together in the networks. But overall, that process of forming and disbanding project teams occurs time and time again in a project-based industry. So this creates a longitudinal fragmentation. And so that's a challenge for digitalization, because what we have right now with BIM merely reinforces these existing fragmentations and tries to find ways to solve them digitally. But industrialization demands a lot more. And the way that we're thinking about this at our research group is thinking about Construction 4.0 as a new vision for the construction industry, and one that can potentially combine several different technologies and approaches together in order to overcome some of these challenges. And this would include a combination of things like BIM and prefabrication that we've heard today. It would bring in new ideas about in situ or offsite robotics, but also has a key emphasis on the cyber physical, the supply chain logistics, and the data management as well. But today, I don't want to talk about all of those. There's a lot there. So instead, I just want to focus in on one specific approach that I've seen emerge in the industrialized construction space over the last 10 years. And I think it's kind of would summarize what we've heard a lot about this kit of parts or this mass customization. So if you'll indulge me, I'd like to talk about product platforms. So let's talk about product platforms. We've heard already the idea of Legos. And so there are different types of platforms. There's digital platforms, but we're specifically talking about product platforms today. And the academic definition here is that we have a platform which is a set of common components, modules, or parts that form a common structure from which a stream of derivative products can be effectively developed and produced. But that's really boring and academic. I think a much better way to say it is that we're talking about Legos, or we're talking about a standard structure that allows multiple products or projects to be built within the same technical framework. And I think it's really important to recognize that platforms by definition are restrictive. So platforms do not enable infinite freedom. The Legos are not infinitely free for design. They have specific restrictions and rules. I call it with my kids the one dot rule, where everything has to fit on this kind of grid of dots. And this is what happens when we have a product platform. We can develop that product platform, and we can start to put our best knowledge, our best lessons into and feed that knowledge into the product platform so that it improves from project to project. And from our standard product platform, which is continuous, we can then derive specific project kits, which are needed, but that we've spent some time designing the product platform. And then from the project kit, you can create different and unique projects. And this is the relationship between a product platform and the projects. And now we heard also the phrase about mass customization. So I think it's important that we also talk about how platforms enable mass customization. What happens is that if you define a hierarchical product structure and your derivative kit of parts, you can start to create options, optioneering, or in the end, mass customization. What mass customization means is that you achieve product flexibility or design flexibility at a very close to optimum production capacity. So if the way of saying it is, if mass production allows you to produce at 100%, mass customization is at 90% efficiency or 95% efficiency. So we have to be careful also how we use the term mass customization, because it refers specifically to a customer and supply chain and production system that comes together. And what we need in construction is that we need to take this kit of parts, and if we would like to apply mass customization, we can then think about what are the rules of configuration. How do we think about the different parts coming together? What are the interdependencies between the parts? And then we can create user inputs or user interfaces, which can allow users to design for mass customization, but importantly, without breaking the rules of the product structure. So a simple way to say that is don't allow someone to design something that does not match with your back-end fabrication system. And in the end, then you have the ability to have a customized product. That's very academic and probably maybe a little bit boring. You've been listening for 2 hours, so maybe I'll just give a couple of examples of how I've seen configurators emerge in the industrialized construction space over the last 10 years. The first configurator I saw came from a company called Project Frog. They're based in San Francisco. And they created their Frog kit, which you see here on the left, a number of SIP panels and I think trusses. They also had some timber approaches as well. And what was really interesting about Project Frog is that they worked on the configurator. They've now moved even more into, I'd say, their kit connect more into software. But they were delivering buildings, but without owning any factories. So their configurator helped them configure their factories or configure their buildings just with a simple interface, right? So here you have the idea that you can, on a web-based interface, add structural walls, add doors and windows where you might need. And then make sure you're not breaking the rules of the fabrication system that you've set up. In doing so, then you can also adhere to local building codes and structural calculations that need to follow so that you can kind of check the design status. And from here, you can automate then the creation of your bill of materials, your component model, your shop drawings, and as well as your permit and construction drawings, right? And this was around 2015, 2016, where they were working on this system. And I thought it was a really novel approach to think about how we can achieve mass customization in our industry. More recently, here's an example from where I am now in Switzerland. This is a company called Mobit, which delivers, let's say, culverts and other types of infrastructure, concrete infrastructure that might be needed on demand. So you can think about the idea of a lot of this work is maybe exploratory, where you have to dig trenches and you might not exactly know the size of the culvert that you need, or you may not want to pre-order because you might not know exactly the excavation conditions. So what their business model is to basically 3D print with a 24-hour delivery time, specific customized fabrication for their culverts and other types of drainage materials. And they specifically do this with their online 3D configurator. You can go to their website and configure precisely the size, and this feeds direct file to factory, I guess you could say, or cloud to factory. When you push order, they begin the fabrication process, and then in 24 hours, you can have your, let's say, mass customized piece of infrastructure. And then since many of you are located in the Pacific Northwest, I thought I would use another example of this for mass timber, which I think is quite exciting. It's from the startup called Intelligent City in Vancouver. And what's really nice is that they have gone to parameterize the product platform. So they developed their product platform, but they've also connected it with parametric design. So here you can see the idea would be that as you change the design, you can change the mix of homes. You can understand immediately the implications and the changes in the production system, and have feedback both to the types of the bill of materials, the panels that need to be built, and if I can get forward, and then also the direct connection to their factory, which they're currently building and setting up right now. And so here you have a direct connection between design platforms that are fabrication aware. The design platforms actually have the embedded rules of the fabrication system in the design platform, but it's also parameterized, so you can achieve a lot of flexibility. And then you can connect this to robotic fabrication on the back end. And here, I think this is a profound change that we're going to see in the future. And I think this is an important thing that this community should also think about. This is what I would call the old BIM approach to industrialization, although I would actually maybe change that to say it's more like the current state of the art. And I think what we just saw from Erica represents the difficulties in this process, but it is also important to get this process right. But the approach that we use is we typically transfer all information downstream. We start with design. We don't really think about supply chain when we start our design, although we should. And so we begin with our conceptual design, and we start just adding things to our BIM, more and more information. The BIM is the repository for each iteration, each more detail. And that's where the level of detail, LOD, comes from. You know, we're providing more and more specific fabrication information until we could get to LOD 400 or 500. We have a fabrication loaded model. Very iterative process with a lot of conversations between your fabrication and your design team. Where we can change is that we can slowly change this away from what we had before, which was approximate precise geometry, and we can start thinking about configuration engineering. And the important point that I'll put here is that the future of industrialized construction is going to be about embedding rules and restraints of your fabrication production system upstream. This will become more important as we continue to add more and more robotics to our approaches. But it could also, it does not necessarily have to do that, because you also can just match your design with the knowledge of your production system. And then I mentioned, you know, it's not just about the new technology or the new approach, but it's also about new business models. You know, if you look at what Steve Jobs infamously said when he first launched the iPhone, there was no, you know, that all of the potential applications could be run through Safari or through a web browser. And he received a lot of pushback from developers until, eventually Apple opened up the App Store, and then you really saw the iPhone kind of explode as you know it today, as a way to magnify the impact of other developers. And I think the question for us is, what do those new business models in construction look like? How will we see new technologies be coupled with new business models? And in fact, here's two pictures of two factory visits that I've made. On the left here was in 2020 when I visited the Katera factory, now infamous for the large-scale implosion. And a lot of people argued the fact that they used a new business model and tried to vertically integrate the whole process was really a major problem, a major flaw. And on the right, I'm there at Beaucleuc. This was in September. This is the joint venture between Skanska and IKEA. It was actually mentioned in the first presentation. And they're setting up their brand new KUKA robotic fabrication line. And I would argue they're probably the most, or one of the most successful industrialized construction modular companies with very high profit levels and doing exceedingly well, also vertically integrated. So again, thinking about what are the implications of such business models for how we think about our design to fabrication systems and our construction. We wrote a little bit about new business models. If you're interested, send me a note. I can send you over the chapter to get a sense of how we see this space evolving. So to summarize the first part, and then I'll quickly go through the second part, how do configurators change industrialized construction? We stop uniquely designing projects, but instead the projects can be configured from a knowledge base that's contained in the product platform. And then that design process must be fabrication aware. We need to think about the implications of fabrication during design, and even better, we need to develop processes and continuity between fabrication and design. If you're going to invest in prefabrication or industrialization, there must be a clear customer focus because you need to understand what choices will the customer want, and even decide who is your customer. Is it the architect? Is it the end user? These are important considerations that need to be made. What I see happening is a transition away from what I would call BIM as input. So the idea that you just put more information into the model. I think we're moving away from that. And instead, we're seeing what I call kind of BIM as output, but maybe a better way is to say Revit or IFC as output. Instead, we're looking at more lightweight kind of computational codes, or it could even be in Grasshopper, that instead are generating these high LOD models as the output, but the actual configuration happens in a much more lightweight computational model. And finally, we're seeing an opportunity for new business models and new supply chain ecosystems. So I have about 7 minutes left, I think, if it's okay if I keep going. And I want to just talk about what I see as the role of research and teaching in an industrialized construction future. As a professor, these are the two of the main activities that we engage in. So, on the one side, it's thinking about the research, and on the other side, it's thinking about how do we about the teaching. So on the research, I'm going to give one view of what might the future of industrialized construction look like, and then you can tell me if you think I'm crazy or if this is possible. And then on the teaching side, it's about how do we empower the next generation of students to lead us there. And so I want to present our project. It's an ongoing project called 7-Day House, Fabrication Aware Generative Design. I don't want to overpromise this. We've only been working on it for about 6 months. And we have 3 more years of work ahead of us, but I do think it's a kind of one future vision of what industrialized construction might look like. Specifically, we're looking at how can we shorten the design and delivery for fabricating millions of homes as top-up units. So the idea of a top-up unit, maybe it's not so useful in single-family homes in North America, but here in Central Europe, we have a lot of dense homes that could add lightweight industrialized construction on top of the rooftop. And one study said there's up to 2.7 million potential homes that could be built through rooftop extensions just in Germany. But if we're going to do that, top-up units have regulations, site constraints, customer preferences, and they really would require a high degree of customization and of course, the involvement of local architects. So how can we possibly use industrialized construction, which is such a modular, boxy type of system, to achieve these beautiful top-up units? we take some inspiration from a program called the 3-Day Car, which occurred, it was a research program in the early 2000s, which essentially looked at the process for mass customization for a car. How could you have a made-to-order car? And the researchers, there's a lot there, I don't want to get into all of it, but what the researchers did is they tried to figure out, if I ordered a car, how long would it take for me to get the car? And the answer was 40 days. So a mass customized car took 40 days to deliver. And their goal was to reduce that to 3 days. Well, when they looked at actually what does it take to deliver a car in 3 days, the production time was measured at 1.4 days. So the actual time on the machine, on the factory floor was 1.4 days. And then there was some time on the distribution, but the majority of the time came on the order input, the order bank, scheduling, and sequencing. And I would say most of this is around taking the fabrication, the design considerations and translating them into the fabrication line. Processing the order was the single greatest bottleneck in the whole supply chain. So there we take some inspiration, and I work together. I'm a construction person, but I work together with a team of also with architects. And I'm going to just jump through this one. We're looking at cross-laminated timber as a construction system because of its high compatibility with fabrication requirements. And then what we're doing is we're thinking about how production constraints can be used to create an adaptive kit of parts library, with the end goal that we can also create a fabrication aware generative design tool, so that in one day we can generate the design and we'd have 6 days to build the house. There comes the 7-day house idea. We need to think very carefully about how do we define, for example, do we think about a panelized system with volumetric, modular bathroom and kitchen pods? We need to think about what does data-driven and real-time configuration look like. Then we're also trying to think about the different edge cases for fabrication, right? So you could think about, you have endless unique parts or a single part on the x-axis here, and you could also, fluctuate between panelized and volumetric modular. And how you think about that has specific implications, right? So if everything is panelized, this is the one edge case, whereas if you have a single part, a panel over and over again, or you can think about what would it look like to have volumetric modular, or with unique parts and specific volumetric configurations. And so we're doing this exercise to help us understand what are the edge cases, and then to create our parameterized and generative design system that can think through things like design language, design freedom, cost, time, and logistics. And the goal is that we want to specifically model things like cost and logistics into the generative system, so we can know the impacts of design choices in that way. All right, I think I'm at 24 minutes, so I'll just quickly jump through the teaching side of things, where we ask the question, how do we empower the next generation of students to lead us there? The question is, if we believe that industrialized construction has potential for disruption, if we think about that this could really be a change in our industry, then how should we prepare the next generation of AEC students to think disruptively? We saw a great example, I thought, in the first presentation about a master's program that combines timber, materials, and fabrication. We need more of these types of things. What do we do in my classes? I think the first step is, of course, to teach the next generation of students about fabrication. We bring them to the fabrication shops and let them actually see what industrialized production looks like. Both the high-end fancy robots and the building under a roof, which you could argue is maybe not, or is just not much more cost effective than doing things on site. But we see both here in the factories in Switzerland. We also need to think about the new roles that we have to train students for. This was an interview I did back in 2020, where someone said, it was an industrialized construction company, we need an experienced senior manager, I think they said 10 years experience, with a hybrid background between an industrial engineer and a construction engineer. And that person simply does not exist. There is not a role, there's not a person with that level of experience, or very few people with that level of experience. So how do we train the students for the new roles that might exist? We do that with my class, where I ask the students to propose a startup for industrialized construction, and we specifically change the names of their positions. They come from architecture, they come from structural engineering, they come from construction management, but I specifically ask them to become the director of product development or technical systems or strategy and market. And in this way, we're thinking about the building as a product, and we're also getting them outside of the traditional mindset of what these things do, what these roles do. And then we also engage in ideas around entrepreneurship. So what does it mean to be entrepreneurial and to kind of change and question some of the systems? So we need to teach students how to think outside of the existing way that we do things and think about new systems to deliver these buildings. And then finally, we should think about new ways of designing competitions and new ways of establishing creativity. This was a conversation I had with Greg Howes, a friend of mine who works in mass timber. We talked about how, on the left here, I just pulled this today from Arc Daily, just a list of all the architecture competitions, right? And these are almost all for a single project, right? Or some kind of a single competition. What would it look like if we moved towards product platform design competitions? How would that conversation change the way that students and creatives would think about their work? They might think about things like structural performance in a much more deeper way. Good. So just to summarize here, and I didn't have time to talk about all of these things, but on the research side, we see the idea of circularity and circular economy, fabrication-aware design, which I did talk about, design and management for digital fabrication, and new business models. And on the teaching side, to summarize, it's the concepts of entrepreneurship, fabrication-aware education, new roles, and new types of competitions. If this is interesting to you, we talk about a lot of these things, especially around startups and new business models at the Stanford Industrialized Construction Forum. It's actually next week, next Wednesday at Stanford. Today's actually the last day for early bird registration. So if you're interested, we do have more room. So please come check it out in person or online. So just a short promo there. With that, I think I've already gone a bit over time, so sorry about that, but thank you very much for your attention, and I look forward to the discussion. Maybe we've provoked from some debate. Let's see.